For today's webinar, I have yet another consumer part. Um, yeah, so I had a really good idea to cover live transfer and talk about some live transfer best practices, kind of a getting started with that. And I had a really respectable consumer part that I wanted to use for that one because it just showed it very well. So it looks like we're on a run of consumer parts here. So let's go ahead and jump forward. Yeah, so here is an appliance bracket that I scanned here at my house. And I was able to take that part, scan it, model it, and then today we'll go through the modeling process and cover what that looks like for this part, but then jump over to live transferring it to CAD to show how you can live transfer parts over. And then I even have a couple live transfer examples to go over to kind of show some things that to be aware of, right? Some things to acknowledge when you're sending over to CAD and how it works. So before we jump in to the presentation portion, the Design X portion, let's talk about the scanner. So this is a one where another white light scanner was used, like this one right here. And you can see it's actually a thin part too, so it shows how accurate these white light scanners are, to be able to flip it over, and that we merged it together as a very thin featured part. So we did scan it with a structured light. You could say structured. I tend to say white light, blue light, but structured light, which this type of technology, if I haven't mentioned it before, it projects a structured pattern onto the part and watches it with cameras, one or two cameras depending on the device itself. And because it projects that pattern, it measures the delta, the change in the pattern with the cameras to understand the depth per pixel there, right? So the 3D, it basically is taking a photo and assigning depth to the pixels based on the offset of the structured, the known pattern that it's projecting on the part. Right? So that's just my simple explanation. I'm sure there's somebody out there that has very familiar or intimate knowledge of how this technology works, and I'm not doing it justice. But I figured I would give kind of like a high level that it's a very, very fancy projector and camera system setup that's calibrated to very, very precise tolerances in order to take 3D pictures of the part. So with that, we can go ahead and jump over into the Design X portion. But as usual, I forgot that I'm going to talk about what Design X is real quick, and then we'll dive in. So as usual, we always start out by just going over this slide, and I will pare it down. As a lot of people are watching my webinar on a regular basis, I know that going over this slide could take a few minutes, and it's redundant for you. But I just wanted to make sure that anybody that's watching this for the first time understands what Design X is really quick before we dive into the application. But Design X is this software right here. It's the software that we use. It is a software that can work with 3D scan data from a variety of different inputs from different devices like these over here on this side, from structured light scanners to laser to handheld laser structured light scanners, time of flight scanners, CT scanners even, all kinds of different devices were creating this type of data, and people were trying to load it inside of CAD, and were struggling a lot because CAD wasn't designed for this type of information. Enter Design X. We create this software that is a parametric CAD modeling kernel with a 3D scan kernel all in one space, right? So then we take this data, do the heavy lifting, and then we extract model information and output it in different sources like you see on the right hand side, whether these are the high level outputs. CAD is the primary, but we also go straight to CNC packages or straight to additive technologies out in the market. So that's what this Design X product is all about. Grabbing that scan data, recreating or reverse engineering that object, and getting it out to whatever is going to produce that manufactured model. So with that, we'll go ahead and jump right into the Design X portion. So here is today's part. And I'll start out by going through the history tree first so we can kind of understand how it was modeled. And as usual, I give the disclaimer that yes, you may model this different. If I gave this part to 10 people, they would model it 10 different ways. And you see, this is a pretty short history tree. I was able to model it in a condensed amount of features here. Very basic, simple part. But it's because I wanted to focus on the live transfer aspect of sending this over to CAD more than modeling features today. So let's go ahead and roll back here. There we go. We'll go ahead and turn on the mesh, the meshies. So there is the scan data. So this is a good point here to show, as you see here, that look at this is a thin feature, and we were able to scan it and capture it, even though it's a very thin piece of sheet metal here, and mesh it together, and it kind of held up. Yeah, it's not perfect. It's got some little bits, but again, this is a worn actual piece that I found. So went ahead and scanned it and used it as a great demonstration piece. So these first things are some planes that were created for alignment, to create the alignment of this part. And then we'll go ahead and sit here, and looks like we did an extrude of this entire part. So real quick, one note that I bring up with people about sheet metal parts with Design X is that we tend to model those sheet metal as 3D parts with their constant thickness, if it is constant, and model it that way and use whatever destination software that you have that is going to flatten the sheet metal part out, because every single software does it slightly different, has different parameters, and even different versions have different, and people have methods and softwares that they've used to do that forever. So we model it as a 3D sheet metal part, as a 3D object, and then again send it over and then flatten it from there. So that is my MO of why I'm modeling it this way, is my little short spiel here. So let's go ahead and show that solid again. So went ahead and silhouetted the entire part. I'll just go into that real quick just to show. Silhouette the entire piece and draw out the overall profile and overdraw this side. So you can see here, just draw out and we made it symmetrical. So I chose which side that I wanted to be the driving side, and go from there. And then went ahead and drew this out, dimension it, do all that. And then we'll go ahead and keep on moving. So then we just cut from the side here. And then extruded up and merge that together. We could have done that in one. Could have done that in one feature. And then went ahead and extruded that block for the top there. So this is what we have so far. And now go ahead and apply a few fillets. And shell it. And I mean, look at how simple this was. It looks, and then you cut those little pieces off. So there it is, and then we can obviously show deviation, and it's going to have some deviation because this is a very low budget stamped out sheet metal part here. It doesn't have to have high tolerances anyway. It's just a little safety thing that they bolt to the floor to hold your appliances from tipping over like a stove. And yeah, so this is the part. And we'll go ahead and live transfer it over. Now, I'm going to show multiple parts today, live transferring, because you'll see this one right here. We'll send it, and it comes over, and it looks beautiful and all that. But I wanted to also show sending more complicated parts and then some skills on doing so. So we'll go ahead and show kind of the baseline here of what it's like to send a part over, and then we'll take it from there. So I'll go ahead and I'm going to use SOLIDWORKS today to send over these parts to. So now I have my SOLIDWORKS screen up. What I'm going to do on the Design X side is hit live transfer and send. So if I just click and show you here, I'm going to hit this on my other screen. So I'm going to come over to SOLIDWORKS, start from first feature, and I'm just going to hit the checkbox on my other screen. So now I have SOLIDWORKS showing here. Don't judge me on 2021. I purposely have old versions installed, a nice old version installed, because we have customers that span the gap of having the latest and greatest and some that lag behind a few years. And I find if I have an older version, I can give people files even if they have a new version. So I like having an old version installed that I tend to use to send over. And this shows that even though I'm using Design X, the latest and greatest, it still goes to an old version here. So that is an important little distinction to make. So while I'm at it here, we'll go ahead and hit send. And you'll see it pop up here on screen. And it kind of looks like an animation. Like you're watching a movie of something happening here. And that's because it kind of is. In the background, LiveTransfer is using the software itself, the SOLIDWORKS, to send over and transfer everything over one for one. So it sends over the individual sketches and all their entities in the same spots with the dimensions and all of that. And it comes across, and then it closes out that sketch, and then it goes and it builds the feature, and then it builds the next feature, and then merges, and it does all of those. You know, it's just, you just see that it built the feature, the fillet across the edge, and then now it's going to go ahead and shell it, and then do the little trim away, and then when it's finished, you'll see here, export succeeded. Now, I do think this happens a little faster, this animation. Now, it didn't take that long. I mean, I'm not complaining here, but it goes quicker when you're not presenting on a meeting like this today or a webinar. It does go faster than that. Um, Now, you'll see here that it leaves some stuff showing. So I actually, if I'm going to do live transfer with my into a CAD, I keep these little view filters handy where it'll say hide all planes, hide all sketches, hide all axes, that sort of thing. Because DX leaves things like when it transfers over, I don't think it's DX. I think when it transfers over, the CAD package has everything showing, right? So there, we just sent this over as native entities inside of SOLIDWORKS. And then if I just extend this out, I like to do it this way. You see here, there is my solid. It's a solid part. And then we can just go right back to that original sketch that we went to before. And if I just go to edit sketch, you see all of this stuff comes across as native entities with dimensions and stuff as well, right? So you'll see that it has the tangency and the angles. Now, I didn't fully constrain this on the Design X side, and I tend to not. I tend to come back and fully constrain in the CAD because this is another difference when you're sending stuff over LiveTransfer. There are differences in the way these solvers for the sketcher solve their constraints, relations, and dimensions. So sometimes they solve slightly different, and that's why I tend to dimension the critical things that I need to pull from the scan and put all those in. But if I wanted to try to make this a fully constrained black sketch in here, then I would finish it in here. That's just the way I tend to work, and it's just a good suggestion there. And you see, everything was native entities. So now we're here, and I could save this part. And now this part is a SOLIDWORKS model. And if it didn't say mesh here on some of these, or have our naming conventions, you would probably never be able to tell that this was modeled somewhere else besides SOLIDWORKS. So it's really a neat functionality, being able to send stuff over, live transfer it over, and get it inside of the SOLIDWORKS environment. So that is our baseline. So let's do another one. We'll go ahead and close this. And I will show my SOLIDWORKS screen. So here is my SOLIDWORKS screen, and here's another part. You can see, we'll just check the deviation for it. And I didn't model this one. Someone else did. And they did it in an interesting way. Sometimes you'd say there is no wrong way. There might be a wrong way, though, depending on what you're trying to accomplish here. But I just say that this one was modeled very different than I think. But you'll get to see it on the SOLIDWORKS side. So I'm just going to go ahead and come over here to Live Transfer SOLIDWORKS from first feature. Now I'm going to show SOLIDWORKS. So here is SOLIDWORKS. We'll go ahead and hit the OK send button, and you'll see it creates a new part. And I do get questions sometimes. You can send this into an existing part. So if you had some stuff modeled and you extracted some of it from a scan data and you wanted to update your model, you can do that as well. So it is possible to send into a current part. If you are not understanding why you would want to do that, there are instances where maybe you have a CAD model and you scan one and you align the scan to the same coordinate system that the CAD model is. And we can load the CAD model in, by the way, from SOLIDWORKS back into Design X to use as a reference to align the scan data to it. and then align it together. And then if you make modeling changes and then send those over to SolidWorks, they'll come in the same coordinate system. So there we go. Export succeeded. You'll hear, just like I showed before, turn off my features. And then you can see here, created a block, rotated. So you can see here, we went ahead and cut away using that sketch there, and created a nice little model. Now, again, nice and clean, send it over, basic, establish a baseline of how this works, how you can send stuff over. Now, let's go ahead and do one that's got a problem with it. So I'll go ahead and show Design X. So here is one of my demo parts that I use often. So if you've seen me present or actually seen anything on my YouTube channel, I do have this modeled every single way possible. I show it for presentations all the time. And it's just a great part that I pulled off my house and scanned and reverse engineered, and it just is a good part to show how to model something. It's just a great example part. So with this one, you're going to see that we have a lot more elaborate geometry. And when you model something inside of a CAD environment, if you've ever switched between CAD packages, that you know that they model differently. So the different CAD packages may have variations as to how they model parts and how the tools work, and even how the order of features can work, different rules associated with those. So for an example that I like to use, we have a tool called Extrude. So if I just hit Extrude and I just click a sketch here, in Extrude, we have the ability to say, I want to extrude this solid and merge it, cut it away, or insert it as a separate body. So even on the most basic level of doing an extrude, there are differences. So if you go to SolidWorks, you would have to do an extrude cut is a different command than an extrude merge. Those are two separate commands. Where we have that is one command here. Or if you're in Pro E Creo world, you can't extrude and have more than one solid at a time. They have a very interesting rule there. So you, instead of having more than one solid at a time, you would have these bounded surfaces that you use to then Boolean or cut things away. So you have to kind of like get creative there. So that's one example. So, and then we're different than some because that's an extrude cut, an extrude merge of a solid, but we have surfaces broken out as a separate extrude. So you're going to extrude something as a surface or extrude something as a solid as separate tools. So there are some CAD packages, I think like NX, if it's a bounded shape, you extrude a solid. If it's not, then you can extrude a surface. I cannot remember, again, all the differences there, but there's lots of little ones. I mean, they even have little ones where inside of modeling, where we do a cut with surface. So I can say I want to cut with surface here. I don't know why I'm just drawing. We have it over here then. Right here. So cut with surface, or cut in our software, you could call that two different commands. I'm using the SolidWorks term or the Design X term. We actually can select multiple surfaces and cut with them all at once. where SolidWorks doesn't let you. They only let you cut with one surface at a time. So keep that in mind when you're setting up your modeling, that if you are a SolidWorks modeler, you're pretty familiar with a lot of those things that are particular to SolidWorks. So you model with SolidWorks in mind if you're going to model in here. And we try to model in a more universal way. Now, another element here to point out is you can come over to this drop down and I can turn on error list and you can select the CAD that you want to go to. So if I say Creo, it's going to say, oh, you can't do this. You can't use a variable. You can't do whatever. NX, you can't do this. You can't do that over there. So make sure to model it that way. Or, if it's just a fillet, you can just leave it out and apply the fillet over there. But this CAD compatibility is made to help you send things over and avoid having problems as you send it over. Now, it's not 100%. There are some things that fail because versions happen. They release new versions, and there's just lots of functionality here. But this is a really good guide to help you. And really, experience is your best guide here when you talk about using this error list. All right. So let's go ahead and hit send. I'll go ahead and go back to the Home tab, come over here and go to SolidWorks, start from first feature, and then I am going to show the SolidWorks screen first, and then I'll hit the button. So here's the SolidWorks screen, hitting the button, and everything's going to start flowing through. Just like it did before, building sketches, adding features, all the things. And you'll see there it creates that sketch. It's going to create this extrusion here. And wah, wah. There we go. So this is an example. So here's an example where it says transfer pause due to build error, fillet full face. So I used a slightly more advanced feature on this where I used a full face fillet. And sometimes you're not even sure exactly what this means when you see it. You're like, full face, I don't understand what's not compatible. But usually, almost all the time, if I just have Design X and SolidWorks open up at the same time and I just look at both history trees, I can see, okay, that's what doesn't go across, and then I can tweak it. So that's what we're going to do right now. So I can hit OK, and you see it leaves off right where we stopped in the history. And again, with my filters, I can hide all the things and clean up my interface and see sometimes I'm not sure what the next feature was when I'm in SolidWorks. So if I jump over to Design X, on the Design X side, you'll see it just leaves off in the history tree right where it had a problem. So it extruded this just fine. And if I roll forward to that, the full face fillet. So if I open the full face fillet and see what it is, you see here that you can select these faces, those faces, and it will create a full round between them. Now, SolidWorks has that functionality as well. So sometimes it doesn't come across, but they have the same equivalent functionality. So I'm just going to jump back over to SolidWorks, and we will create a full face fillet over here. So if I just come over to fillet, and I come over to full face fillet right here, and then say items to fillet, faces 1, here, there, and then hit OK. So it doesn't like it, and I think it's because some CAD packages, if I just apply a fillet here, let's just switch over to just our regular fillet and clear that out. just create a 10 millimeter fillet there. I think it wants tangency around there, which these are just skills that you pick up as a SolidWorks user or a DX user. That there are certain things that the tool is struggling to create. So you see now it's able to create that full face fillet. Hit OK. And that will this will never come into play because that area is going to get cut away. So let me just show the Design X side. Back to Design X. You see here, I'll go ahead and accept that, just get out. If I turn the scan on, you see that gets cut out anyway. So just applying that was no big deal. And then what I do is, because I applied the fillet in the timeline over in SolidWorks, I'm going to skip past it, select the next feature, come back in here, say resume from selected entities, selected sketch 5. So we're just going to skip that in the timeline over here because I already have it in the timeline over there. And then I'm going to hit the checkbox and let me show SolidWorks again. Back to SolidWorks, hitting of the send, and just let it keep playing. And just let it keep. There's all the cutouts. And this is where planning out your features to be simplistic or along the lines of how that CAD works can make the process easier. So now, here's another one. Transfer pause due to build error. Fillet constant rebuild. So let's jump over to Design X. On the Design X side, roll forward. Now, you see here, for some reason, it just does not like this fillet right here. And it could be, sometimes it's literally just, did you click this edge or that edge? What edge did you click to say what, to route the fillet around the edges, right? The other thing I'm going to do is I'm going to apply it manually. So we're going to do 22 thousandths, and then we're in inches. So we'll come back over, and we will do another fillet. Switch over to click. So you see how it propagates all the edges? It just looks for tangency all the way around. And then I'm going to say 20 thou. I will say there are some people, because fillets tend to work different in different CAD packages, that will just leave them out if possible, and then apply them in CAD if they have issues with things coming across. So now on the Design X side, we do what we did before. Click on the next sketch. Resume. And let it go forward. And now we're continuing to send. All the way to the end. Export succeeded. So we just had a couple little bumps in the road. We made modifications to the timeline. So now we have a fully featured CAD object here inside of SolidWorks, just like we talked about before. I could save this as a SolidWorks part file, send it to somebody, and they might not even know that this came from another software. And you can drop this into a assembly, into all kinds of other plugins, drawings, whatever it is, to create whatever deliverables you need here.